It looks like we're live, mostly. Such. It didn't work. Anyway, wait for the video. Volume ain't too good, but I think it'll have to do. Yeah. I might have my volume settings down or something. I don't know. But it doesn't really matter. It's close enough. Probably. I hope. That's what we'll just assume. All right. I guess I should do comments first. At least there are any. And we'll bounce around and do this and that. Probably something like spectral lines, which are quite interesting, and velocity of electrons. And what's the implications of their theory, whatever their theory is, on the subject of electrons? Because I'm not quite sure what their theory is. So anyway, go live again. I'm bored. Okay, that's very interesting, but I don't know. All right, I won't delete it, but it's stupid. What is the? I do it when I do what I can do when I can do it. Period. What is the page this strip guy is referring to? Well, I guess I ought to post the link to it. I have it here somewhere, right? Demonstration. That isn't it. Yeah, that's old crap. What the hell is this? Gravitational lensing. Oh yeah, that's more of the crap. Just absolute crap. So that's the old crap. That's some new crap to deal with. What's this? I think this is the Sage page, maybe. Pontclair. Oh, it's got to be something else. What the hell is this page? Some Wikipedia page on something. No, it's the Sage. Yeah. Anyway, I have to surrender. I don't know where I put it. All right, so well, I'll try to remember to post the link. Even ever thought about fixing your audio so it doesn't sound like a hollow drum? Well, frankly, this whole audio thing, go through all kinds of trouble with audio and blah, blah, blah. But live rooms, I guess you just don't know this, but live rooms are always a little poor audio-wise, because they're streamed and the sound is compressed depending on bandwidth and all these issues. So you're just out of luck, fucker. Complainer. Ugh. Assholes. All right. So now the whatever he is, the climate change denier. Some notions are popular because they are remarkable. Virgin birth is remarkable. Well, it really isn't, because in the Bible there's other virgin births, so it's kind of unremarkable, actually. Therefore, it is remarkable upon the belief, and the belief spreads. Well, whatever, that's your theory. I think people want answers, and sometimes you don't have an answer because you don't have enough information to provide an answer. And people will believe what's to their convenience. So if they can, if you have a choice, a man is coming to dinner or a woman is coming to dinner, blah, blah, blah. One guy might say, well, is it fuckable? And that'll be the truth he wants to be. That's a woman coming. And, it all just depends on incentives. And whether they're scared of aliens or whether they think aliens will bring them candy. That kind of thing. The notion of space-time is remarkable. It's an extraordinary claim. That's what I would argue. And it's so inconsistent with what physics does in terms of providing answers, right? I mean, up to that point, physics has been pretty disciplined in not jumping to silly conclusions and saying, that angels pushed the planet Earth into the sun. I mean, the serious scientists knew, oh, no, that's not the answer. And they just didn't fall for magic answers. And they were so, you know, answer deprived for so long a period that when Einstein gave them something that sort of worked but is crazy, they just went with the it works part. And you can sort of see that in Feynman's rhetoric, which is sort of related to, because that's what I've been reading his old the lecture book, you know, based on the lectures. And so I've heard a lot of the arguments, but the book is a little more detailed, so it is better. That has it's the actual lectures he gave at Caltech. Yeah, what do I? Well, whatever. The notion of space-time is remarkable. I would argue it's outlandish. You know. But anyway, therefore it is believed. No, I think it's believed because people want an answer, and it also provides an answer that creates mystery, and you know the universe is powerful and there's stuff going on that we don't know, so it kind of opens the door to all kinds of, well, maybe the unicorns do exist, and maybe God is hiding in the bent space, you know, ice arena or something. Humans delude themselves into being incapable of distinguishing between what is remarkable and what is true. Well, human beings are, they have a huge bias, selfish biases. So they have optimism biases, they have fantasy story biases, they have happy endings versus sad endings biases. And so they want this a story, a narrative that says positive things about them and provides the opportunity for them to delude themselves into thinking they're playing a good game, or it's a good world, or it's a good universe, or blah 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 blah. So that's all it is, and they don't really give a fuck about standards or the truth. They're just hypocrites. You know, when it's time to convict them of jaywalking, they want you to have a pile of evidence. They want you to prove it. You know, but when it's time to answer fundamental questions in physics, proof smoof, evidence smevidence. Just tell me a good story that works, you know, which the Invisible Man works, frankly, is if you want to get out of, you know, accountability for a crime you commit, just say the Invisible Man did it. It works as a theory. All right, D. Hilster is a hand waver. Well, aren't we all? You seem kind of hand wavy. To tell you the truth, James, you seem pretty panicked that somehow everybody doesn't know everything there is to know about water. He won't discuss details. I don't know. He doesn't have details. So, yeah, how can he discuss what he doesn't have? You know, I mean, the small Earth thing brings up so many issues. I was thinking some more of atmospheric ones, you know, because as you make the circumference smaller, it's 4 times thing. It's that whole inverse square law thing in reverse in a way. And so that means the ions in the atmosphere would be a different percentage. And, you know, that would really screw things up. Anyway, you should not be so sensitive, and she should not be so blatantly political. Well, I don't know. I think it's okay. But yeah, it doesn't, I mean, you should keep the physics separate from any other crap. These dumbed down rhetoric is worthless. Yes, dumbed down rhetoric isn't worth too much. You can use generalizations and simplifications as long as you recognize that this is what the actual evidence and the actual details indicate. But these people don't have any of the actual evidence or the actual details, and they're just clinging to kind of made up generalizations. And I would argue that Feynman did the same thing. When, to his convenience, we don't need evidence. When the truth being proven has something to do with something he's agreeable to, evidence, but if it's a truth that he has a little bit of, you know, apprehension about, well, then he's cautious, and, you know, we can't know, and we don't have enough information, and we don't have experiments to make exact calculations, and we can't, you know, he's full of caution about drawing conclusions. But when it comes to Heisenberg, oh, fuck, who needs real evidence? We'll just assume that it's the universe that says things don't have a position. It's not the fact that it's impossible for us to measure positions and momentum at the same time. Yeah, fuck that. That fact that it's impossible for us to do it, that can't be the reason we don't know the answer. The reason we don't know the answer is because the answer can't be known. I mean, that's just crap. There is no answer. The thing doesn't have a place. Anyway. All right, so then James does his typical bullshit of, I'm going to post a link to my crap. My tinfoil hat theory. iGraph science. I suggest watching okay, we did that. So the comments are just thin and not very useful, I'm afraid, tragically. And Godspeed, Andy Conti lips. I don't know. I guess I can block that, right? I mean, that doesn't sound. If somebody's talking about lips in a physics conversation, yeah, I don't think we need that guy around, right? And you Ninki. I don't even know what that is. Yeah, so Godspeed, fuckhead. Fuck you. Yeah, people. All right. I mean, there has to be some kind of reward and punishment here, right? I mean, if I could tax these people, they have to put a quarter in to get in the room, and you get a quarter back if you behave rationally. And, if we had some sort of mechanism where, then yeah, I could just steal their quarter for being an asshole. But this is all I get as a reward and punishment mechanism, is this ability to say, fuck you, and click the button. So I'm going to use whatever tool I got. That's the tool I got. All right, so where was I? Oh, yes. So, all right, so let's go to the Feynman lecture page. So it's well written, these lectures. And, I wish it was almost performed by Feynman, and you could just hit the spot where he says something and blah, blah, blah. And I've sort of done that with his, where he does the 2-slit experiment. I've done it where he's talking about Lesage gravity. And, where he doesn't even name it, which is kind of funny. And he sort of misrepresents it here in this lecture, in the sense that he says this is an idea. So he's talking about Lesage, who's the guy who picked it up 100 years later. I mean, the first guy actually did talk to Newton. It actually was an idea Newton was agreeable to. So this, he just kind of, again, they break the context. The truth is sort of, who cares? Let's just tell the story this way instead of, accurate to the facts. All right, so what do I really want to get to? Let's see. I'm just trying to think of what order I do this video in, because this spectral line stuff is also an interesting subject. So I was looking at that. That probably is this way. These are really, it's pretty. The Wikipedia page is pretty nice. These are pretty nice little slides. And, so you have hydrogen. And so you're saying this simple little atom, it's creating 3 really sharp lines. And those lines are, kind of representing a balance that exists inside the atom, in the sense that something goes, any kind of stuff can go in, and this is the thing that's likely to come out, kind of thing. The more likely bounce. So it's like a system, some sort of preloaded system where you're getting an average. So let's say how to do this. I'm just trying to think of a common analogy, but I'm not thinking. I can't think of one off the top of my head. But the idea is you put, $1.25 into, a big collection of $1, and a dollar pops out. Not it always converts whatever energy goes in. It quantizes it, so it sees, well, there's the dollar part, so it makes a dollar, and then it has the 25-cent stuff that it just uses as like jiggling energy. And the only thing that comes out is the dollar. So whatever you put in, you put 75 cents in, a dollar comes out, and there's less jiggling in the bowl. And you put $1.25 in, there's more jiggling in the bowl, and a dollar comes out. So it's that kind of thing where you could imagine there's electrons in certain positions. Now in hydrogen, that's not really going to work, but you can imagine that they would have energy between them, tension. And if something disturbs one of the electrons, that disturbance will be blended across all the other electrons. And so it'll always be averaged. And so in the sense, if the electron doesn't change the energy level of the electron, that is, expand the pressure, then it releases the pressure. And if it releases it in this averaged quanta. And it is sort of true that these spectral lines can be a little fatter and a little thinner, depending on heat and different circumstances. So that sort of implies that the average can be a little different depending on the state of the atom. So you can get $1.04, or maybe 97 cents, out of the system. And each one of these lines would represent a different system, that is, a different part of the atom you're hitting that's in tension. Something like that, anyway. But it's not a purely consistent thing where you say, okay, yes, hydrogen has 3, and then helium will have 4, and then lithium will have 5, and you'll just go down the list, and it'll all be this nice ordered. And no, it doesn't work that way. Helium. Look at all these lines here, and lots of little faint ones here you probably can't see. Lots of lines, maybe 12, 15 lines, and then you go all of a sudden lithium, you're down to 3 again. So there's not a real huge correlation between the number of lines and the atomic weight, which makes it a little tricky. Now the trick is that some of these could be the spectral lines of the ions. So these are more than one atom that you're getting the spectrum from, and the mixture of a group of, you could have a pile of lithium, and half the lithium could be ions of one form or another. So they could be producing lines in different locations because of the different pressure having, or, if your system is made of 5 electrons and it has a certain size, if you add a 6th electron, the size changes. That kind of argument. The pressure changes. And so ions would produce different spectral lines. Supposedly, I would imagine. Yeah, I have to imagine, because I'm just not sure. I think the ions have a different signature. I just don't remember. So anyway, it's an interesting subject based on just trying to figure out what's the cause of these lines. What's the actual mechanical cause? And like I said, I think the cause has got to be related to this idea, that the atom has a steady state where there's certain pressures, and those pressures are represented by frequency, in the sense of the ping pong ball bouncing between things. And it's really about the amount of pressure decides the rate at which these ping pong balls can be released, what frequency they'll be released at. And so any disturbance of the atom, any agitation, you heat it, and you're knocking energy into it. That is, you're pushing electrons. You have this circle of electrons, let's say, and so when you push one in, again, that's an incursion into the other. So think of it as a hexagon. So and if you push in any of the points, and the electrons will be on the points, you can sort of understand that the lines get longer, in a sense that you're taking a bent part of the triangle and moving it into the hypotenuse, and so there has to be more pressure going out this way. So electrons have to absorb that pressure, and if it's enough pressure, it will equal, an electron being thrown out, because you absorbed a photon, and increased your pressure. Something like that. I'm just going through my head. So again, you have to think about the whole system, and it's the fact that it oscillates and it does all kinds of things. And so the photon is really released in the reaction to the action, not in the process of the action. Something like that, generally speaking. Anyway, so that's an interesting subject. All right, the one that I thought of today was this electron thing. I've pointed out how I believe it's a fact that electrons and protons can't. So you can set up a field, an anode and a cathode, and you can make electrons fly to the charge difference. So the voltage is pushing them. So you have a current, essentially, that pushes the electrons. And as soon as you stop the current, the electrons start losing momentum. And so you can't just shoot an electron that has created a current, accelerated an electron, and then the electron just keeps going. So I can't shoot an electron, have an anode and a cathode, create a current to move the electron, just remove the cathode once it gets going, and just allow the electron to just keep going. It just won't do it. In my opinion, that's the truth. That's what the evidence indicates. So when Feynman's talking about motion in here, so he first concedes, and he said it in both the audio lectures, the performance art lectures, and in this written lecture, that, so this is an accurate quote, they don't have a cause for inertia. So he concedes we don't have an explanation for inertia. Why does something keep moving? How is something different, when it's moving and when it's not moving? Because you have to think about it in terms of the fact that it does have, if it has orbitals and it has stuff moving in it, why is that stuff moving in some other direction besides it's just going around thing? Somehow there has to be some kind of, how does an electron know when it's spinning around that it's supposed to also go this way? That's kind of a complex thing for the electron to be doing. And the neutrons and the protons, how do all those little bits know they're supposed to keep going? So how does an atom know, with all these little moving parts in it, that it's got to go this way? It's like, you can imagine that if the sun was moving somewhere, that there would be evidence of the drag. So it has to spread the velocity to everything that's around it, or as it moves, there's going to be all kinds of lag in how the Earth picks up that motion. It's going to stretch things into all kinds of weird shapes and all kinds of stuff. So until everything else catches up, there would be huge deformations, that might just rip the whole thing to pieces, depending on how fast you move the sun out of the system. Because the rest of the stuff, there won't be enough force to move it with it. Well, anyway, so inertia is not a simple subject. It's not a nothing subject. It's a pretty substantial part of physics, is the idea of perpetual motion, the idea that I throw a wrench in space and it keeps going. If no force is acting on it, the force just keeps going. It just keeps moving in that direction. And there's no mechanical explanation for what physically changed. Some of us might recognize that obviously the space doesn't change. so the change, whatever the difference is, it has to be somehow, the information has to be in the object. Some element of the object has to be doing this go that way thing. And you could argue it's dragging the rest of the stuff with it, but I'm arguing that that doesn't make much sense. It's really all the little bits somehow have to be programmed to know they have to keep going. And if you think about the fact that the atom might have photons actually captured in it, then you can also kind of realize that those photons captured in there, they're already going the speed of light. If they're ping pong balls bouncing, they're doing this. They can't do another velocity in another direction. You have to actually physically change the way they're bouncing, so they bounce in the direction you're going. You can't. There's no way you can make a photon go two directions. It can't go the speed of light this way and 50 miles an hour that way. All right, so this is really an important question, and he has no answer for it. And then in that context, he, makes this declaration that, the external force theory of gravity can't be true because of this drag issue, because of inertia, essentially. And to me, it's just such a how can you discount something based on a problem where you admit you are completely without a clue how it works. So you don't know how inertia works, yet somehow you know that there's no way that there could be a mechanism creating a physical mechanism that creates velocity. And so, it's such it just demonstrates his hypocritical standards. So, when he's doing other people's physics, he's disciplined. He's Newton. He's like cautious. Let's not jump to any conclusions. We don't have enough evidence. But when it's his conclusions, the ones he's comfortable with, then it's like, okay, we don't need to know the subject in any depth. We're just going to make a declaration and say the hell with it. I mean, it's really pitiful. It's pitifully obvious that he has these double standards about what when you have evidence to draw a conclusion and write law. He always talks about these laws. Well, they talk about modifying laws, and I'm like, well, you shouldn't really write them as laws. You should write them as suggestions. Until you know it's a good law, until you know it's a solid statement. So anyway, equations can model the energy transfers. And again, that's the argument isn't, this is also a problem with Feynman. Is again, he's basically saying, in some respects, who cares about cause? We have a theory of effect. So yes, equations model effects. They don't model causes. I guess I could say that really strongly and say, don't you fundamentally understand that there's a huge difference between modeling an effect and saying, look, I have an equation that gives me the right answer for what's going to happen. But there could be 50 million different ways it actually happened. You can write the probability for, rolling dice. And you could say that's the answer. That's what the probability is. But the real reason could be because there's sides to the place you threw the dice, or because the real variables and causes of that probability could be a numerous different structural reasons. So math is not doing, in my opinion, is not physics. You don't walk into a courtroom with probability and say he's probably guilty. It's just bullshit. You could say that the wrench absorbed energy. That's obviously what I'm saying. That's not what they're saying. On the atomic level, wouldn't it come down to electromagnetic repulsion between electrons? So again, that isn't saying much beyond the fact that, again, you still have to explain how it's the drag issue. The more you move into this, the the argument is an external pressure would mean that the force is a real force and it exists in the space. And that means that if you're plowing through the force, there's going to be drag. That is, you're going to hit more stuff in front of you than coming from behind you. And so the issue is you have to explain how motion through that field is possible. Now, even if I take away the field, you're still left with the problem of explaining why something travels distance and why it doesn't, in the sense that there's no mechanical explanation for the physical difference between the moving pen and the non-moving pen. And there has to be a difference, logically. Something has to be different. The same universe can't be doing two different things, is the point. So obviously there's something actually physically different, and they don't have any explanation for that difference. So there's two aspects to this argument. All right. But yes, everything comes down to the repulsion between electrons. The repulsion between electrons is 95% of the universe, something like that. And the other 5% is the protons mitigating from the safety of their central position that pressure. So they're less influential because they're so far away from the war. I mean, the soldiers win the war, the generals make a contribution, that kind of argument. The electrons are the on-the-line soldiers doing the work, and the protons are the behind-the-lines catalyst, conduit, regulator of that function. So, yes, I would agree that it is a change in this function. There's just so many things to go over. Just even the titles of these chapters and how he gets into the subjects. And I was thinking, like, obviously one of my chapters would be force, and just acknowledging that light is a force, that we have found the speed of force, not the speed of light, and that this is a much better way to understand what's going on in the universe, that there's these two types of things. There's force and then there's matter. Yeah, and so there was another point I wanted to make that was important like that. I think, well, I probably will get to it again. Just in terms of these headings and understanding what's really happening. All right. So the real point I want to make is, so I was thinking of atomic theories. That is all this particle accelerator stuff, and how they create these new particles. So I was thinking of this problem with the electron. Now I don't think they believe. I'm just not sure. It's a hard thing to find any documentation on. Do they understand that electrons lose velocity just traveling through empty space? Like if I push an electron into empty space, whatever velocity I push it at, it will lose that velocity and stop. If I can take it out of all charge influences, all things that might affect it, it will just go and stop. Now, we can't see electrons in that circumstance, quite obviously. So we can't see them do that. So the only way we see them is to have them plow through a medium and create a signature, a bunch of sparks. So it's basically we can't see them ride on asphalt. We have to see them tear the asphalt up. So we have this assumption that what's slowing them down is the fact that they're plowing through the asphalt, not that they're just driving on the asphalt. So because every time we look at them, we're watching them in a medium, and we are calculating that, yes, the medium is a drag element on the electron. It's hitting things. It's hitting ions. It's hitting things, and when it hits things, it's losing its momentum. And so the idea is they're just basically seeing particles that fly out of a piece of material. They shove radiation into a material, they see the particles come out, and they have a certain speed, and they assume from that speed what the particle is. So if it's moving too slowly, then they say it must be a big heavy thing. And if it's moving too very fast, then they say it has to be lighter than something. And so then they call it a new particle because it's too light to be an electron, or it's too heavy to be a proton, or it's too something. And I was thinking that part of this problem is they're not recognizing that these things are always going to slow down anyway. They're not acknowledging that. And that's part of the equation. So they're not accounting for that. So they think more of an event happened than actually happened, because they're not calculating into the event the fact that it was already slowing down. So it's like if the Volkswagen's driving down the road at 30 miles an hour, and you're going to hit something at 50 feet, or you're going to hit something at 100 feet. Well, if you hit it at 100 feet, the Volkswagen's only going to go 10 miles an hour because it's slowing down. And if you hit it at 50 feet, it's going to be going 20 miles an hour. So the interaction is going to be happening at a different speed. There's no standard speed for the electron. Its speed is always changing. And so that's the problem. Because obviously you don't have a current pushing the electron. So if you're shooting electrons through a piece of lead, let's say, obviously you don't have a anode and a cathode and a piece of lead in between and have any hope that you're going to be able to push electrons that way, because the lead's going to absorb the current. So there's no way to keep pushing them at a constant speed and have them crash into something, because what you're really doing then is just crashing a lightning bolt into something. You're not crashing the electron into something. You're crashing the pressure into something. All right, well, anyway, so I thought of that, and I just said this might be a viable reality, that the whole particle zoo is created out of a misunderstanding of the real nature of an electron, which is it will lose velocity by a real, in empty space, by some calculable, predictable amount. It's essentially, it's plowing through something, And so it's another way of proving my theory, I suppose, is the fact that if they concede that electrons do this, they slow down, then they'd have to concede that something's slowing them down. And what's doing it? Well, it's that drag issue. They don't have an engine to get over the drag. They don't have any way to keep plowing through the drag. So they're succumbing to the drag, quite simply. And I think that's a real viable argument. But clearly, it's a little bit complex, but it's not, it's not 4-level chess or something. This is a fertile ground to play with, because it's a pretty simple fact. Either the electron does slow down in empty space, or it doesn't. If it slows down in empty space, you have to explain why. Why does it slow down in empty space? Does physics have an explanation for that? Why can't I shoot an electron to the moon? Why can't I just push one, far enough out of the gravity of the Earth at a high enough velocity to get it going, that it should be able to escape, have escape velocity and make it to the moon? Why can't I do that? And the answers would be appreciated. So anyway, so that's the value of me going back to this. So the whole point is I went back to this just because I wanted to see if his Lesage argument was any deeper in this written version than it was in the performance version. And it had absolutely, it was, in some respects, it was even weaker, and it was the same rain argument. Well, you get hit by more rain in the face than in the back, so therefore this whole theory has to be thrown out. I mean, it's just this superficial dismissal, where just a few paragraphs earlier he admitted we have no theory of inertia. And so he admits they don't really understand why things move fundamentally, and yet he's dismissing a theory based on a component that's completely related to the generation of inertia. You know, the fact that something has a velocity that is maintained. So I just find that it's just kind of duplicitous. That's all. That's the word I'd use. I mean, it's just a double standard that's, you know, shouldn't be legal, quote unquote. All right, so yeah, I guess this stuff I'll have to put in a video and attempt to solicit somebody who knows something about it and all that kind of stuff. But you know, it's like all these. I guess no one's going to show up that can do any of that. But anyway, let's see, what else do I want to do here? All right, I think that's electrons and the pressure, and yeah, that's probably enough. So anyway, so it's very well written. You know, it's easy to read. Not too much math so far. I'm like up to chapter 6 or something. So you know, whatever, it's 50 chapters or something. Anyway, yeah. And you know, and it's appealing in the way he's presenting it, in the sense that he's presenting it as physics connected to all the other sciences in a way, and just all phenomenon we see, and trying to get to the fact that there's a physics answer to chemistry, and there's a physics answer to biology, and there's a physics answer to all these things. It's all physics. And that's something I've been saying for years, is that there's really only one science, it's physics. So, you know, I'm agreeable to that kind of thing. And the rest is this idea of the jiggling. You know, he's sort of famous for that concept, but this idea that everything's just collecting attitude. But again, they don't have a mechanism for the collection. They just assume it's some sort of native function, where I would argue it's an acquired function. You don't jiggle till something jiggles you. So there's the jiggle is from something being caused. Again, not just jiggling because it has stored jiggle. It's jiggling because there's a force that's where the randomness is in this motion, but the motion isn't random all the way down. The motion is random to the Planck constant. It's like heads and tails. So he uses heads and tails as an analogy in the probability argument and stuff. And there's always going to be this variation. There's no, you know, you can't make the absolute prediction, because the variation doesn't provide you the option to know, unless you actually do know where every single interaction in the event. And if you don't have every single interaction in the event, the tiniest of interaction in the event can decide the event. So, you know, you have no hope of ever making a completely accurate prediction about whether something's going to be heads or tails. Even when you have a lot of information, it's never going to be enough, unless you have information regarding something that's decisive. Like one side of the coin is heavier than the other or something. But again, you're still not going to be able to overcome, if there's any possibility of having a tail versus a head, you're still stuck with the when will that event happen. If it's 1 in a million, you won't be able to predict it's going to happen now, this time, you know, out of all the possible times. And that uncertainty is built in to the function of the universe, in the sense of the universe itself is there's nothing random, in the sense of the mechanics of the universe aren't random. There's an explicit amount of something hits, something doesn't hit, but there's no way to have information of those trillions of events to know, oh yeah, 2 things in the next second two more things in the next second are going to hit from this side and then from this side. And there's no way to know that. And so that sort of gets to the Heisenberg argument, where again, this is just such an example of where he doesn't provide any logic. So he does all this. He extensively goes into the logic of this probability thing and different things like that, where this is the limitation of our science. We can't do this. We can't go further than this. And yet when it comes to Heisenberg, which is a simple question, is it a limitation of our measuring tools, or is the particle actually quantum leaping? So this is sort of the question, right? So you can cut quantum mechanics down to a simple argument. The idea is that we could both agree that the electron, as it moves through space, is in fact going to be found to be at different locations in space if you could know. And it will land, certainly, in various locations as a possibility. And we can't predict which location exactly it's going to land in. Now, the question is, do you believe that that's because the electron doesn't have a location and it just quantum leaps to all kinds of random spaces? It doesn't travel from here to here or move or do something like that, that it leaps, it just jumps to so it lands in these different locations based on a leap. Okay, not because it was heading for it. And the point is not because we don't know that it actually has a position and it moves in a straight line. So when a photon goes somewhere, by their theory, okay, the photon doesn't have a location. All right, but the leaps don't take any time. So if it is here at 1 second in its travel, it could be up here at 2 seconds. So 2 seconds, it could be landing at this part of the target. And at 3 seconds, it could be over here. But these leaps don't take any time. So it wasn't like it had to take a curved path to get anywhere. But anyway, so it's a simple sort of question. Is the fact that we can't slice thinner slices because we don't have a tool to slice thinner slices, that is, we can't see it because we don't have a seeing device, or is it unseeable in the sense that its very nature is it's invisible? And so I would argue they have absolutely no evidence that invisibility is the fact. They have no hard evidence whatsoever. They can't point to some experiment that proves invisibility is a real thing. All they have evidence of is this probability of the fact that we can't narrow the probability, that we don't have a tool to narrow it. We can't see any finer resolution. And that's all they have as evidence. So in my opinion, it's clear that you side on the obvious, which is, yes, we just can't see. The answer isn't that it isn't happening, that there isn't a real position, that the photon doesn't travel in a straight line from point A to point B, when everything indicates that that's exactly what happens, that there is no quantum fluctuation beyond the fact that we can't see very well. The blurriness is in our eye, not in the thing itself. So just like my poor vision doesn't mean that the letters on this page are fuzzy. It's my eyes. My eyes are causing it. So that's the real question. And in my opinion here, he has this assertive conclusion. It's definitely the letters are fuzzy. When it seems the obvious place to look is, no, the eyes suck. And, that's just so fundamental to this whole subject. And because, like I said, who's arguing with the probability statistics? No one. Who's arguing that photons don't have interaction with materials and change their direction? Of course they do. So the real argument is not not in describing the effect. The argument is in describing the cause. And for them, the cause is quantum leaping when clearly the cause is that photons aren't produced in a mechanism that's reliable. The gun doesn't shoot perfectly straight, period. That's the explanation. And if you put a slit in the way after you shoot it out of this imperfect gun, yes, the photon will interact with the material surface. So again, he goes into great detail describing atoms and the empty space in the atoms and all this kind of stuff. And yet, you know, again, it just occurs to me to say, well, why then in these experiments where photons are interacting with surfaces, aren't you at all, why doesn't it occur to you to recognize that the surface there isn't any distinction between the air and my finger? On the surface of my finger is a whole bunch of layers. You know, one of them is a layer of water, and then there's a layer of steam. There's all these layers. So it's not even a pure transition from actual finger, whatever that would be made out of. Well, seawater. You know, there's layers. And so, of course, when you're shooting photons through those layers of atmosphere, you'll get a different result. You throw a baseball 2 feet off the ground, and you throw a baseball 20,000 feet off the ground, or 60,000 feet off the ground, or 100,000 feet off the ground. And let's just assume the gravity was the same. You understand the baseball is going to fly entirely differently because there's a different atmosphere it's flying through. And so it just seems, again, I guess I can't argue that he's ignoring something or deliberately discounting. But the fact that it never occurred to him to take all of his understanding of how atoms aren't solid objects, he knows that. So why does he think in a two-slit experiment the surfaces are a solid object that can't have a variable influence on a photon? Of course, the surface could have a variable influence because the surface is a variable medium. The medium, the deeper you go, the more it changes, and the further out you go, the more it changes. There's change happening there. The transition layer, and transition layers aren't consistent. So it's just so, in my opinion, so obvious that there's this gradation from a surface, and that gradation could completely account for why photons move at a new angle. But again, he's just so emphatic that these functions are quantum functions, that is, leapy functions, and that they're not mechanical functions. Yes. So, nothing from you people. Nothing? Nothing? Is there any people? See how many people are here? Can't do better than this. Like I said, I should just make videos, I guess. With drawings or something and all that crap. Ooh, that's incredibly unpleasant. Ooh, 16. Eesh. 16. Not great, but should be enough for some sort of comment stream here. So you people have nothing to say about the speed of electrons, Heisenberg, emission and absorption lines, pressure, just nothing, huh? All right. So let's see. Let's go through these chapters. Atoms in motion. So atoms in motion was more about atoms jiggling. The first chapter, I think. And so it sort of gets to the argument that it doesn't. He has a separate chapter on conservation, but it sort of smells of stuff goes in, something comes out. Nothing. Everything's a chain of interaction. Really doesn't really say that. Trying to think of what atomic process was, but it didn't really start off going into much atomic process. But anyway, there's something else that was quite clear he was talking about in that first chapter. What the hell was it? I'm trying to think of the analogy he used, but I can't think of it. But anyway, he used the kid block analogy for conservation. The idea that you have a kid with blocks and the kid can hide the blocks in all kinds of places, but the energy can never be destroyed. It can just be hidden, can't be destroyed. Which does get me to the trap argument, right? So that's what I would have. One of these chapters would be titled The Motion Trap, because this is really what this is physics. Is that you have this stuff moving, this force moving in straight lines in directions, and what's fundamentally different than that, okay, is a car traveling across the country or something, going to California, from the East Coast to the West Coast, is the fact that it gets caught in a circle and it gets stuck and it just goes around in a circle. So it's like two fundamentally different functions for these little force bits. The little force bits can travel in a straight line and go and go and go and go, or they can interact with an atom and get stuck in a cul-de-sac and just go around and around and around and around and bing, 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 bing. They can just reflect. And as I've pointed out, the square is a circle, but in a sense, the even shorter circle is up, down, right? You end up in the same location, up, down, up, down, up, down. You always end up back where you started. So in a sense, it's circular. But it's a trap, right? So the ping pong ball goes into the paddle and it bounces off the other paddle. And if it goes back and forth, it's a trap. And that is like such in my opinion, that's the eureka thought for me about this, in this whole theory. That was the real eureka moment, was just this recognition that that's the obvious thing that creates the universe, is the traps, right? The traps are what's creating these lumps, these clumps, and that, yes, everything would just be stuff moving the speed of light if it wasn't for this clump, this clumping. That's the function, that's the thing that makes all the rest of the things possible. Because now once you trap things, you can trap them in all kinds of neat ways, where this one's trapped going this way, and then there's one trapped going inside of that one, and then you can have another one trapped inside of that one, and you can have loops and chains and all kinds of bizarre shaped cul-de-sacs. Roach goes in, Roach don't come out, Roach motels. You can create all kinds of very complex civilizations. If you made a Roach motel big enough, right, you'd put the Roach in and they would evolve and have an old new environment inside the motel, right? They could end up having just as interesting a world, micro world, inside that little box as was in the big world. And it's just a different box with a different amount of I hate this. It just sucks getting old. What's the word for heat? Thermodynamics. What's the word for the entropy? So yeah, you can have all kinds of places that have a different amount of total energy and dispersed energy and all that kind of stuff, colder and warmer and all kinds of different environments. And that's the nature of creating complexity. And it's just really, you create complexity out of a simple trap. Interesting. That's what I have to say. Okay. I just mean it's not very, I need moozing sometimes. I need people to inspire my conversation a little bit, because if it's just me talking, I've already heard what I have to say. So it's hard for me to sometimes pretend, okay, just pretend you're a stupid person, ask a simple question, and I have to ask it to myself. And that's playing both parts is just more work, that's all. It's easier if the stupid people show up, and then I don't have to pretend to be stupid and try to imagine what the stupid people would say and then respond to it. So it's that kind of thing. Then I make a suggestion. I don't know. I'm really not interested. Really not. It's just fuck you. I'm the one making a suggestion. I'm making a suggestion that some of you assholes answer my questions that I've asked about your weak evidence physics. Why are you so devoted to something so weakly evidenced? Isn't that just a religion? Will you answer that question? Isn't it just a religion when you believe something based on very weak evidence? Isn't that sort of the definition of a religion? Faith, belief without, I don't need substantial evidence. No. I believe it because it's fun to believe. What else do you have? You have very insubstantial evidence. So I'm the one making suggestions. All right? I'm not looking for them. I'm not soliciting advice. I'm explaining to you that you people have got the wrong answer. You're deluded and living in a fake reality based on very poorly chosen facts. And you ought to grow a fucking clue. Quit humiliating your intelligence and recognize the diapers you're licking, because that's what physics is handing you, dirty diapers, and you're eating it like it's food. You're falling for it, and it's such crap. As you have the same good ideas and points, whatever that means, same good ideas and points as what? Some of your vids are worth a view, but the problem is, whatever, you have too many. Frankly, it's a unification theory and it's physics. It just ain't going to be that simple. And with really no titles, well, they do have titles, but these are conversational videos. And so they're even a draftier part of the draft science. So some of them are titled when I know what I'm going to talk about. And so this is just kind of whiny as to what the topic is or what topics are covered. It's hard for us public. I don't think that's a good excuse, frankly. I think it's a poor excuse. The video is titled Talk Physics. The range of subjects is a pretty broad range in many cases, and sometimes completely up to you assholes. So I'm giving you the opportunity to have your answers, your subjects engaged in, the ones that you find curious or interesting. And here you are whining. Yeah. But it's the same old bullshit. Nitpicking, naysaying, backseat driving, but no answer to my simple question. Why are all these intelligent people willing to accept vacuous answers to fundamental questions that are supported by putrid evidence? They've accepted a theory of bent space, whatever the fuck that is. It's just invisible man manipulated space. It's just basically saying God done it. It's an absolutely empty answer for an event, a very energetic event. The earth is being pushed into the sun with a substantial amount of force. If we had to do the pushing, all right, by making rockets, it would be a big fucking flame that's pushing the earth. Big flame. An event that powerful is taking place, and the excuse is, nothing. The magic man did it. And they're accepting it. There's no evidence of the magic man. No evidence that the space does anything whatsoever, that space is anything but nothing, that nothing has no arms to pull Earth in with. It has no mechanism for doing this, whatever this crap is. It's a nothing explanation. And then on quantum mechanics, you have this silly Heisenberg thing, this silly notion that the The blurriness in the reality, okay, is something in reality. Reality is blurry. It's not our eyes that are blurry, making it blurry. No, reality is blurry. And you have no evidence that it's reality's fault. And you have every indication, every single bit of indication that it's merely a limitation of our senses and our tools and has nothing to do with reality. Reality isn't randomizing anything. We just don't have the tools to see what actually took the fuck place. Now, you could just point out that, yeah, you're right, that's crap. Why the hell? We're suckers. Why are we arguing with this guy? Because, yes, that's clearly what's happened. They come up with silly answers, dark matters, voodoo, blah, blah, whatever, pions, ions, wakadons, all kinds of fucking, absolute crap. And you just eat it up. Tell me another bullshit story about how the gravitational wave was caused by the three solar masses of matter being converted into bent space, for which there's no theoretical mechanism that it could possibly work that way. But go ahead and believe it anyway. And you're complaining to me about my performance, when this is the performance of physics in which billions of dollars are spent on it, and prestige and Nobel Prizes and all this bullshit, and you're not saying this shit to them? You don't have any problem with their performance? Shit. No. Yeah. Just so bizarre. So anyway, like I said, I'm up to like chapter 6. I haven't gotten any. Like I said, it's just in the overview you get the idea. He's really emphatic that we're not going to talk about causes. We're just going to establish the fact that we can formalize the event, and we can create factors and variables, and they're close enough. They work, and that's all that matters. And to me, that's just saying I quit. I don't want to do physics. I just want to do math. You stop being a physicist once you do that, in my opinion. You're not looking for the cause. You're just saying I have statistics that say husbands kill wives more than, let's say, badgers. Okay, so badgers don't kill too many wives. Husbands kill a lot more wives. That's all. That's all they're going to say. That's a good enough answer for us. We don't need any more details. That's enough. We can answer enough questions with just that information, so we won't pursue it any further. And he's not entirely saying that, but he's certainly saying it when it comes to the fundamental questions like Heisenberg. He's certainly saying it. No point in even thinking about it. I'm a real smart guy. I tried to think of it. I couldn't come up with any answers. He's basically saying that. I tried to think about gravity without bent space. I couldn't come up with an answer, so therefore there's no answer. Einstein must be right. I mean, it's very arrogant. Arrogant's not even the right word. It's very self-aggrandizing. Like he's competent to declare when, oh yeah, it's impossible. You can't do it because I can't do it. So it's like me saying, no point in somebody trying to run, a 4-minute mile because I can't do it. I mean, it's just really silly. So, so chapter 7 was the gravitation one. It was pretty much word for word what the lectures were in a lot of respects. And it had a little tiny bit in there about Lesage and the fact that it doesn't work, so there can't be any other possible theory. Just dismiss it. Don't try to make it work. don't think about it a little bit, just dismiss it. I think even conceded that there are a couple of people trying to come up with some other mechanism. You know, this was written like in the 60s. And so I guess, you know, there's probably not a couple of people anymore. You know, a better description of gravitation than Einstein's bullshit. But yeah, it was just totally dismissive. Like, this is bad. It's just a waste of time. This works. That's, again, it's just this stupid "it works" argument when it's not really working. First, because you don't know how much you're missing by not getting the truth, by not getting the details. Having the details can make it fly a lot better. So it's like they got a drone, and the drone does this, you know, wobbles up and down, does this and this, and they're basically just saying, well, that's all I want to do. I just want to go off the ground. I don't care if it crashes. I don't care if it flies into trees. All I care is it goes off the ground. That's my standard. And then saying the drone works. When you know, no, if you work on this thing, maybe you can get it to fly level and you can get it to do all kinds of things. And, you know, you don't give up and just settle for it's off the ground. You just settle for the whole story. You settle for as much as you can have. And they're just closing the door, basically, and just saying, we're satisfied that this vague image is good enough. Vague image with magical events. Yes, we'll just accept magical events, magical randomness, and magical bends in geometry. And that's good enough. We can use it to predict, and that's all that they care about. And it's you know, that sucks. It's like convicting somebody for the wrong reason. You know, they're guilty, and there's a real way they did the crime. And yet you go into court and you basically prove that, yes, they're guilty, but you have a completely wrong explanation for why they're guilty, how they did the crime, why they did the crime. Like, you have everything wrong. You have their motive wrong. You have their method wrong. You have every detail wrong. And you just say, well, it's good enough because we got the right answer. But it's really not good enough. I mean, the right result. You know, bad guy convicted. But he's not convicted for the right crime, kind of thing, even. You know, it's just totally unsatisfactory. So you people really are, you know, nothing. So nobody wants to talk physics. Okay. So I'll give you the, whatever, 5-minute warning. Ugh. 3-minute warning. Maybe it's just a 2-minute warning. One-minute warning. Yeah, so I guess I'll just go back to my internal conversations. They're more productive than these external ones. And blah, 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 and such. And so forth and whatnot. Maybe a chance anyway.